Hello, my name is David Wang, and today I'll be talking to you about visualizing medical data, or medical visualization. But before we can go into medical visualization, we must first ask ourselves, what is a visualization? Specifically, data visualization. Data visualization is a graphical display of abstract information. It can be shown in many different forms, such as graphs and charts. We can even go beyond that and display information in other mediums, like 3D. Among other things, data visualization itself can come in many different fields, from geospatial to scientific to even medical. Today, we will be focusing more specifically on medical visualization. Here I have a video that showcases the potential of what the possibilities are for medical visualization.
In the past, art and science have combined to depict the human body. Now, the visualization of human anatomy has made another giant step. On August 5, 1993, a cadaver was imaged from head to toe with the same magnetic resonance imaging and computed tomography equipment used in medical diagnosis. So much for the familiar. The cadaver was then encased in blue gelatin and frozen to -160 degrees Fahrenheit. A custom-designed cryogenic macrotome was used to remove 1 mm sections of the rock-hard block, revealing slice by slice the beauty and detail within. After each pass, high-resolution color digital photographs were taken of the remaining block, yielding the first digital description of an entire human being. This seminal collection of 1,878 aligned images are displayed in rapid succession to show the three-dimensional nature of the internal structure of the human body. The light blue areas which appear throughout are cavities in the body that were filled with latex prior to imaging so that underlying structures would not be confused with the current image plane. Predominantly vertical structures such as the spinal cord, trachea, esophagus, major blood vessels, long bones, and many muscles can be followed through their entire course. This national resource is part of the Visible Human Project, sponsored by the National Library of Medicine. It was created at the Center for Human Simulation at the University of Colorado Health Sciences Center in Denver. It is in the public domain and on the internet. The cutting and imaging process produces undistorted, precisely registered data. Evidence of this success can be seen when the dataset is stacked in virtual space and views of the same cadaver are reconstructed in alternative planes. The vertical black lines seen in the reference human below represent missing data, an artifact resulting from the process used to divide the visible human into blocks small enough to accommodate the macrotome. We can stop the animation at any point and identify a number of anatomical structures. Computational scientists and anatomists are working together to isolate and classify anatomical structures. From these data, scientists produce three-dimensional renderings. The shape, color, and texture for the renderings to follow come directly from the data. Here, separate structures which make up the detail of the knee are displayed. The fleshy bellies of the powerful muscles of locomotion, the weight-bearing tibia and femur hinged at their smooth cartilaginous interface, and the superficial veins that bracket the knee joint. As the mechanical properties of the tissues are defined, we can begin to interact with the body in the virtual world of real anatomy. The ability to do real-time manipulation of the anatomical volumes in space is critical to the development of effective and realistic surgical simulators. Anatomical databases might also be used to simulate pathological conditions such as tumor growth.
Access Visible Human Database. Display axial section with hypothalamus. No. hypothalamus. Select tumor type 2. Position. Grow.
This is just the beginning. The visible female is coming this fall to an internet near you. She will exhibit the same 1/3 mm X and Y resolution as the visible male, but will improve the Z resolution from 1 mm to 1/3 of a millimeter.
As you can see, there are just some possibilities we can achieve with medical visualization. Now, of course, how can we achieve such possibility that would be better for our patients? Well, first we need to look at how we should be presenting the information to our patients. There are 4 things we need to consider when we present this information. The first is staying true to the data, making sure that the visualization represents truly to what the data shows. The second is communicating your visualization by design and using things like images and charts, not using words to express your data. The third is the usage of color, making sure that color describes your intent on the data. Lastly, we need to make sure that the dimensions of your visualization match the dimensions of the data. For example, making sure that a 3D histogram is not used to represent data that is 2-dimensional. Upon presenting this data, we must also look at the infrastructure and physicians using this system. The first is creating visualizations that can help the physician operate in a timely fashion. That means making sure that the visualization does not disrupt or stop the workflow of the infrastructure. The second is creating an ecosystem for physicians to be using visual tools, such as OSIRIX or Cytoscape. The third is facilitating team decision-making, where visualizations can be analyzed by a group of researchers to determine the best decisions for a given situation. The fourth would be creating visualizations that would help physicians find similarities in cases, eventually figuring out patterns that may help discover the cause of the disease and how to treat it. The fifth is making visualizations that would show comparative effectiveness evaluating different methods and treatment for a particular disease. The sixth is presenting risk and uncertainty in the visualization in terms of figuring out the possibilities of a treatment being successful or not. Lastly, evaluating on the visualization helps show how effective the visualization was in terms of use and relaying information to the patient. Overall, we can use these methods of visualizing medical data to help our patients better understand how to make the right choices in having a healthy lifestyle, and to help physicians provide the right treatment and information to help make the patient have that healthy lifestyle.